Hey, grade 12s. It's me, Miss T. And we are going to continue on our discussion about compound and simple interest and comparing the two of them. Now, the other day in class, I got you to work through an example over a span of 4 different years, right? Either 1 year, 2 year, 3 or 4 year, where you invested $1,000 at the same interest rate and saw what your accumulated amount or your future value was. Now, we kind of noticed a few things. Thing number one that we noticed was the value that we earned in simple interest was constant, which means I think we earned $50 after the first year, which means 2 times $50 or $100 after the second year, or 3 times $50 or $150 after the third year. And since that value that you earn is interest only on the principal, we notice that the graph of my simple interest values, my accumulated amount over time, is going to be linear. When we took a look at compound interest, our compound interest not only earns interest on the original principal, right? That's why we're seeing more than just $50, but we're earning interest on the interest that we also earn, which is why we had just over $50 in the first year and a little bit more than $100 after the second year. And we noticed that every single year that we calculate it for, the gap's getting bigger and bigger. Like the gap was $1 and a couple cents in year 1, but we're close to $20 gap in year 4. Okay? Because as you earn interest on your interest, you accumulate that added money faster. Now, I've actually graphed these two exactly from this example on Desmos, just so we can see and extend the graph bigger picture without having to actually calculate things forever. So let's take a look at it. Now, a couple of things. These lines that I'm making appear and disappear are just the X grid lines for year 1, 2, and 3, and 4. My red line that I'm flashing on and off right now is my simple interest graph line, and the blue one here that it's flashing on and off is the graph of my compound interest. Now I could zoom in here and take a look, and I'll notice that the intercept is 1,000. Now in Desmos doesn't understand context, so technically there are negative X values, but we know that those negative X values aren't really a thing. We know they don't exist in this context because you can't think or can't trace the money back before you invest it and expect it to follow that same pattern. Like you might have had that money at home in, I don't know, a shoebox or under your bed or whatever, but it wasn't following the same trajectory. So it doesn't make sense for us to include negative time. But in both of these cases, this blue graph and this red graph both have an intercept of 1,000 because they both start off in the same place. Now, when I take a look at it after 1 year, if I click these values, I should notice the same exact values that I was able and you were able to calculate the other day from our table. Right? We have 1,050 for simple and 1,051 and 16 cents for my compound. Now, what I do want to point out is the shape of my graph. Right? This is pretty much as far as we got yesterday. Right, this is that red line, that red vertical line is as far as we graphed. But I do want to extend the graph and notice that as time goes on, look how much faster that blue line starts to just skyrocket up. Let's talk about after 20 years, if we were to calculate this. So in this case, I'm looking at this blue vertical line I've just added. If I invest that $1,000 20 years from now, if I invested in that simple interest account, I will get $2,000. So I'll essentially double my money. Very exciting. What a time to be alive. But if I'm taking a look at that compound interest investment, I'm at $2,700 and obviously some change here. But that's a pretty drastic difference. I bet you'd all look at this and go, yeah, I'd love 700 extra free dollars because I didn't do anything different. I didn't touch the money. I still invested the original amount. But compound interest tends to have that growth be an exponential growth because this is an exponential graph. And if I zoom out excessively, like let's look at 40 years from now, I mean, who's investing money for 40 years? Maybe your retirement savings plan. Yep, that's why you invest early. Look at it skyrocket. Simple interest, we're only at $3,000 in 40 years, but compound interest, we are at 7,358. We are more than double what our simple interest investment would accumulate to. So we're seeing this drastic difference the longer time we have that money invested for. Okay? So, going back to what we were talking about, we do want to talk about advantages and disadvantages for simple and compound interest. And some of you, a lot of you, will actually be thinking like, hey, compound interest, that seems pretty good, especially if I'm investing money. That's a fantastic thing. Why am I not just using compound interest all the time? Simple interest has like its own unique advantage. I wouldn't say its advantage is, far widespreading. There's like one good thing to use simple interest for. But otherwise, we're looking at compound. But that one good thing about simple interest is it is good to have simple interest for loans, but only for loans you will not be paying off right away. So say, for example, I take a $50,000 loan for, I don't know, whatever, maybe a brand new car, but I can't afford to pay off that loan or start paying off that loan for the next 5 years. Well, that first 5 years that I'm not paying it off, I'm still accumulating interest on it. But at least with simple interest, in that time that I'm not paying it off, I'm only being charged interest on the principal. I'm not being charged interest on the principal and my already accumulated interest. Essentially, that's the only really good spot for simple interest that we're going to be talking about. Which means that's the only bad spot for compound interest. So the one time we don't really want to go with compound interest is it's bad for loans. You will not be paying off right away. Oops, I forgot the word be in my other words. Not be paying off right away. So essentially, one type of interest's advantage is the other type of interest's disadvantage. Okay, when we're talking about compound interest, which is pretty much good for most other cases, we just saw it's really good for investments, right? We looked at that 40 years on Desmos. We zoomed out and we went, hey, I'm making like $7,000 something as opposed to $3,000. That's huge. So it is good for investments. And that was true in both the short term and the long term. Obviously, it's worth it more if you have it in the long term. But $1.16 in a year is still extra money I wasn't anticipating. So, any investments. Compound interest is also good for loans that you are making payments on. The reason that it's good for loans that you're paying off or you're making payments on is because when we talk about what you're being charged interest on, in simple interest, it's always that principal, it's always that original amount. But when we're talking about compound interest for loans, as you're paying it off, your loan gets smaller, which means you're being charged interest on a smaller amount rather than always that original larger amount. And because when you have a loan, paying interest is not ideal, it is not a good thing for you on that end of that exchange. You want to be paying the least amount of interest possible. So I want to be charged interest on a smaller amount rather than a larger amount. And as you can imagine, I'm about to copy and paste what I just wrote for compound interest and its advantages, but then say it's bad for those exact same things. It's a disadvantage for simple interest. Simple interest is not the ideal choice for investments. I feel like bad's a little bit of a harsh term. It's still good. You're still earning money, right? It's not the worst. You're not paying things on investments. It's just not as good as it could be. So it's bad for investments and for loans that you are making payments on. I would argue that it is in fact bad for loans that you're making payments on right away. I wouldn't say that bad's a harsh term there. It's just bad. You'd be owing more. It's not ideal. Okay. We are going to kind of shift gears completely and go from comparing simple interest to compound interest to be talking about the doubling time of an investment. Now, when we talk about doubling time of investment, I'm talking about how long it takes for an investment to double in value. And it doesn't matter what it started at, it's just going to be twice as big as what its initial was. So if I invested $1,000 and I'm doubling in value, that means how long is it going to take for it to be $2,000? But same idea, if I invested $5, how long does it take to double, aka to be $10, right? But same idea, if I invested 20 million, when it doubles, it will become 40 million. The size of that original investment doesn't actually change or impact how long it takes to double. Hold on, sorry. Okay. Oop, screen flipped on me. All right. So there is something called the Rule of 72. You could probably imagine, based on the formula, why it's called that. But the Rule of 72 is used to estimate the time in years needed for an investment to double in value. Okay, dear Lord. All right. Couple of things to kind of keep in mind. The size of the investment doesn't matter in the estimation. Second of all, the word estimate is key here. The only way the only way we can estimate in this unit is by using the Rule of 72. So if you see any question that says estimate the blah, it's always going to be using the Rule of 72. Okay. A couple of things about this rule. It's T is equal to 72 over I. Pretty straightforward in terms of its calculation. But I don't love the variables it uses because it uses a little baby tiny t to represent the time needed to double. But what I don't like about it is specifically it uses a little baby I to represent the interest rate. Why I don't like it is because in TVM, we used a capital I when we were talking about the interest rate as a percent. We used I%. But in this calculation, it is crucial to leave that interest rate as a percent. So if it's 5%, we are not converting it to 0.05. We are leaving it as that number 5. Now, other things. This is an estimate. Everything that we've been doing before this can accurately calculate the amount of time it'll take for something to double, right? If I'm talking about simple interest, I'm just talking about my accumulated amount, my A value being twice as large as my P value, and then solving for T, okay? If I'm using compound interest, I'm just noticing my FV is 2 times as big as my PV. And I can calculate it and figure out the exact value. The rule of 72 just gives me an approximate, okay? Something that I'll also point out, approximates aren't always perfect, right? But the approximate is best when our compounding periods are annually. That is to say that it's not terrible if my compounding period is monthly or my compounding period is semi-weekly or bi-weekly. But my estimate is more accurate if the question asks about a compounding period that's done annually. So I can use it whenever. It's just the most accurate when it's compounded annually. Okay. Let's just jump straight into examples. I said the little note already, so we could just kind of move on. So, the first question, how long will it take for an investment to double its value at 4% per annum? Okay, this question has so little in it. But one of the reasons I could tell it's a rule of 72, even though it doesn't tell me to use rule of 72, and it doesn't tell me to estimate, is because I have no other information. If my other strategy was to look at TVM, I need way more information for TVM. And if my other strategy was, for whatever reason, this was simple interest, although it does not say simple interest, so we assume it's compound, I still can't use the simple interest formula because I don't have enough information. The only thing it actually gives me is the interest rate, which means my only way to go about doing this is to use the rule of 72. And the rule of 72 is this. T is equal to 72 over I. In lieu of I, I'm putting that for the interest rate expressed as a percent, and I'm plugging it in. Easy peasy, beautiful, breezy, cover girl, however that slogan goes. But I plug this in and I get 18 years. Now notice the question didn't even tell me how big that investment was. Because again, it doesn't matter. That investment could be a nickel. That investment can be $576.32. The size of the investment doesn't get impacted by its doubling time. It's all about the percent of my interest rate. Okay, next one. Same question, but how long is it taken for the investment to double its value at 12% per annum? Another thing that I'll kind of notice as a hint, I'm just copying things down blindly here. Something else that I will kind of notice in the question that helps me know that it's rule of 72, other than the fact that I can't do TVM and I can't do the simple interest calculations because I don't have enough information, is because the rule of 72 talks about doubling time. So if I see double in anything, or like some amount that is almost like a power of 2, so like doubling, quadrupling, getting 8 times as big, or getting 16 times or 32 times as big, they're all powers of 2, then I could look at that and think, oh, okay, this might be a rule of 72 thing. If I'm saying triple its size, yeah, rule of 72 is not going to work here. So just something else to kind of notice as a hint or a way to kind of pull that from the question. All right, hopefully you plugged this in. You got 6. Okay. We have one last question, and it's about Skylar. Skylar invests $5,000 at 3% per annum when she's 18 years old. How old will she be when her investment is worth twice its original value? Okay. When we take a look at this, again, it doesn't say that it's simple interest. We have to assume that it's compound, which means If I wanted to do this in any other way, TVM would be my option, but I don't have enough information for TVM. Okay? So I'm going rule of 72 here, which means I'm going T is equal to 72 over I. I know that I is 3, which means when I plug this in, I get 24 years. Now, the question wasn't about how many years it would take Skylar to double her investment value. It asked about Skylar's age, right? If it takes 24 years, Skylar invested it when she was 18, then Skylar's age is going to be the sum of those two things. So 18 plus 24. Skylar's going to be 42 years old. Crazy times. Now notice this number doesn't actually do anything. This 5,000 doesn't do anything for me at this point in time. I might notice it comes into play a little bit when interpreting questions down the road, like maybe B or C, who knows, I don't know. But that's where we're at. Okay, let's look at B. We want to know how old she'll be when her investment is worth 4 times its original amount. Okay? So something to kind of consider, we just figured out it takes 24 years to double. When something's 4 times as big or could quadruple, that's just doubling twice, right? Because 4 is just 2 times 2. So if it took 24 years to double, it'll take 24 times 2, say it with me, 48 years to quadruple. Now, just like the last question, I don't really care about how many years it takes. What I care about most is Skylar's age. So, how old is Skylar? I'm so glad you asked. I'm going to tell you. She's going to be 18 plus the 48, which does equate to 66 years old. Maybe this was Skylar's retirement gift to herself. She invested this at 18, and she's like, I'm 66. Now I have 4 times as much money. Especially if that 3% interest rate. Again, that $5,000 did not come into effect in this question. Now, the last one. The last question says, how old will Skylar be when her investment is worth $40,000? Now, let's take a look at this. If Skylar started at $5,000, how much will she have if she doubles it? So after those 24 years. That's right, she's going to have $10,000. Just so that you know, when I'm picturing me asking you these questions, I picture you all enthusiastically screaming it out loud to a projector. Okay, what if I double it again? How much money is Skylar going to have when she's 66 years old, aka in 48 years from now? Well, if I double 10,000, I'm going to have 20,000. That's incorrect. Skylar's going to have 20,000, not me. I'm not Skylar. Now, if I double it one more time, Skylar's going to have 40,000. So this number here is kind of important that we knew that 5,000 at the beginning. Now, when we talk about this question I purposely put in the rule of 72 section. But I do want to let you know that if this was a question that was kind of like mixed into the review, very often when it's just kind of not super evident that it's doubling, right? That is oftentimes where you'll see like estimate or use the rule of 72 to determine, to kind of give you that nudge or that hint that we're using the rule of 72. In this section, we're talking about the rule of 72, so it kind of makes sense that we're using it. But I just wanted to kind of point that out. Okay, so if that first doubling time took 24 years, the next one takes another 24 years, the third one takes another 24 years, which means all together, those doublings took a total of 72 years to double 3 times. Because 24 for the first double, 24 for the second double, 24 for the third double. But again, I don't care how long it's going to take. I want to know how old Skylar's going to be. So, let's figure it out. Skylar's age is going to be 18 plus 72. Skylar's going to just be a young pup. She's going to be 90 years old. Barely retirement age. Just kidding. But that's how old Skylar's going to be. Okay. That is it. Today we talked about compound interest versus simple interest. And we also talked about the rule of 72. Just a quick reminder, rule of 72, you can use it as an estimate. It is best estimated when we're compounding annually. You can technically use it for simple interest. It's just not as good or not as spot on of an estimate. It'll be close-ish, but it won't be perfect. If we were given more information, like if we were given the compounding periods, right? How often it compounds, we would be able to use TVM, right? So in TVM, I'm kind of doing an aside here, right? But I'm looking at all of the inputs. There's a lot of things I do know, right? I know the I%. That's 3. I know my PV in this particular question. I didn't in the other ones. If I'm talking about question A, I know my FV because double my initial will be 5,000. That gets to 10,000. But it actually doesn't matter what the initial amount is. Even if I wasn't told what it is, I could plug in $1 and then say my FV is $2. It won't impact. There's no notes about Skylar making payments, so PMT and PY would be those defaults. PMT at the bottom would be end. I know that I'm looking for the number of years, so I know it's going to be 1 times something to give me the number of years, but I'm looking for end. The only reason I can't do TVM here is because I don't have that compounding periods a year. If I was given simply that one extra piece of information, I could not only estimate it, but I could also confirm my estimate or see how close or dead on my estimate would be. Okay? Okay, that's it. That's all. Have a good rest of your day. Bye.